Hey everyone, welcome back to the Deep Dive. We're all about getting you up to speed on the big developments that really matter. No information overload here, just the key stuff you need to know.
Right, to the point as always.
Well, people are busy, they want to understand what's happening, but they don't have time to wade through endless articles and reports.
Absolutely. Efficiency is key.
Exactly. So today, we're taking a deep dive into something pretty fascinating, a major new release from Google DeepMind, Gemma 3.
Gemma 3.
Yep. And we're going right to the source, their own technical reports, to really unpack what makes this family of open language models so significant.
Sounds like a plan.
Yeah, because we're not just talking about incremental improvements here. This is a pretty big leap. Multimodality, longer context, better multilingual abilities. These are the kinds of advances that have the potential to really shake things up.
Absolutely. Game changers, potentially.
For sure. And what I find really interesting is the range of models they've released. You've got everything from a 1 billion parameter model, which could even run on your laptop, all the way up to a 27 billion parameter powerhouse for those with high-end GPUs. So it's designed to be accessible to a pretty wide audience.
That's a smart move, making this kind of cutting-edge AI available to more people. Democratizing access, you could say.
Totally. Okay, let's jump right in. And I think the most eye-catching feature has got to be the multimodality. Gemma 3 can now understand images. It can actually see.
Yeah, that's huge. It's not just about text anymore.
Right. So how did they actually pull this off? I mean, how do you teach a language model to interpret visual information?
Well, they've integrated this really interesting component, a specially designed SIGLEP vision encoder. It's a pretty substantial model in itself, with 400 million parameters.
Wow, 400 million just for the vision part.
Exactly. And SIGLEP has been trained specifically to understand visual content, to break down an image into what they call soft tokens.
Soft tokens.
Yeah, think of it like translating the image into a language that the existing language model part already understands.
Oh, I get it. So it's like converting the visual information into something the model can process alongside text.
Precisely.
Pretty ingenious. And they've done some clever things to keep the processing efficient, right? I mean, images can be pretty computationally demanding.
Right. They've streamlined things by condensing the visual information into a fixed set of 256 vectors.
256 vectors.
Yep. That happens during inference when you're actually using the model, so it speeds things up considerably.
Makes sense. Now, what about the fact that images come in all shapes and sizes? Not everything is a perfectly square Instagram post.
Ah, good point. You're right. Real-world images are all over the place. So to handle this, they've implemented a technique called pan and scan, or P&S.
Pan and scan. Okay, tell me more about that.
So basically, if you have an image that doesn't fit the ideal input size for the vision encoder, which in this case is 896 by 896 pixels, they essentially tile the image into smaller, non-overlapping sections. Then each of these little crops is resized to fit the encoder's preferred dimensions.
So they're kind of breaking down the image into manageable chunks that the model can digest.
Precisely. And this ensures that the entire image is processed, even if it's awkwardly shaped or super high resolution.
That's a clever workaround. And is this something that happens all the time, or is it only applied when needed?
It's an optimization that happens during inference, so it can be bypassed if raw speed is the priority. But if you need that extra flexibility to handle a wider range of images, P&S is there to do the job.
Okay, that makes sense. It's about finding the right balance between processing efficiency and the ability to handle real-world visual data.
Exactly.
Great. Now, let's move on to another area where they've made some pretty remarkable strides, the context window. They've increased it dramatically to 128K tokens.
128,000 tokens.
Yeah.
That's a lot, like a whole book's worth of information.
It is, right. Most of the Gemma 3 models can handle this massive context window, and even the smallest one, the 1 billion parameter model, manages a very respectable 32K.
Yeah, that's still impressive.
This opens up some pretty incredible possibilities, right? You could summarize entire documents, have really extended conversations where the model remembers everything that's been said, analyze complex data sets.
The potential applications are pretty mind-boggling.
But I imagine that managing that much information in the model's short-term memory must be quite a challenge, right? Isn't there something about the KV cache growing exponentially as the context length increases?
You're absolutely right. The KV cache, which is essentially the memory used to store the key and value states in the attention mechanism, can really balloon in size as you feed in more and more data.
And that can lead to significant slowdowns and make the model much more resource intensive, right?
Exactly. So what's really impressive is how the Gemma 3 team tackled this challenge head on.
Yeah, I was really intrigued by their solution. What did they do?
They introduced a really clever interleaving strategy for their self-attention layers. For every single global attention layer, which can attend to the entire 128K context.
Wow, the entire context.
Yep. For every one of those, there are 5 local attention layers.
5 local layers.
Yes. And these local layers only focus on a much smaller sliding window of 1024 tokens.
So they're kind of dividing and conquering the attention problem.
Exactly. By restricting the full attention mechanism to just 1 in every 6 layers, they dramatically reduce the memory footprint of the KV cache.
That's brilliant. So they've found a way to process this massive amount of information without overwhelming the model's memory.
Exactly. They also tweaked something called the ROPE base frequency, increasing it from 10,000 to 1 million, specifically on those global attention layers. This helps the model keep track of where different pieces of information appear within that vast context.
So they're not just reducing the computational burden, they're also ensuring that the model can still effectively understand the relationships between different parts of the input, even across those long distances.
Precisely. It's a really elegant solution.
Really impressive. Now, let's talk about the improvements they've made to their multilingual capabilities. It seems like they've put a lot of effort into making Gemma 3 more adept at handling a wider range of languages.
Absolutely. They've completely revisited their approach to training data from multilingual tasks. They've added both monolingual data, meaning text in a single language,
Got it.
and parallel data, which is text paired with its translations in another language.
So they're giving the model a much richer and more diverse linguistic diet, so to speak.
Exactly. And to address potential imbalances in language representation, they've employed a strategy inspired by research from Chung and colleagues in 2023.
That makes sense. You want to make sure that the model isn't just becoming even better at English at the expense of other languages.
Right. They've also made a significant change to their tokenizer, the component that breaks down raw text into the units the model processes.
Oh, the tokenizer. That's an important piece of the puzzle.
Definitely. Gemma 3 now uses the same tokenizer as their Gemini 2.0 model. It's a sentence-piece tokenizer with a vocabulary of 262,000 tokens. And it's been specifically designed to be more effective for representing non-English languages.
So they're using a more linguistically versatile tokenizer. That's a smart move. Okay, let's get into the nitty-gritty of how they actually built these impressive models, starting with the pre-training phase.
Right, the foundation.
Exactly. What can you tell us about their pre-training process?
Well, it's similar to what they use for Gemma 2, but at a much larger scale. I mean, we're talking about a truly enormous amount of data.
Give me some numbers. How much data are we talking about?
For instance, the largest Gemma 3 model, the 27 billion parameter one, was trained on a whopping 14 trillion tokens.
14 trillion. That's hard to even fathom.
Right. That includes the new image data and the expanded multilingual text we were just talking about.
So massive scale. And they're also leveraging knowledge distillation during this phase, right?
Yes. All the Gemma 3 models benefit from knowledge distillation. This is where a smaller student model learns from a larger, more capable teacher model.
So the student is trying to mimic the knowledge and behavior of the teacher.
Precisely.
I like that analogy. Now, with such a vast data set, how do they ensure its quality? I mean, you don't want to be training these models on garbage data or, even worse, harmful content.
Of course not. They have a whole suite of filtering techniques to weed out unwanted or unsafe content. They're also very careful about removing personal information and other sensitive data.
So they're being very proactive about data hygiene.
Absolutely. And they do a lot of work to decontaminate their evaluation data sets to prevent the models from simply memorizing answers they might have seen during training.
That's smart. It's like making sure the test is fair and the students haven't seen the answers beforehand.
Right. And they also use quality reweighing to downplay the impact of any lower quality data that might slip through the cracks.
So a multi-pronged approach to ensuring data quality.
Yeah, it's very thorough.
Okay, so they've laid a solid foundation with this pre-training process, but then they need to fine-tune the models for more specific tasks, right? Especially if you want them to be good at things like chat and instruction following.
Absolutely. And that's where the instruction tuning, or IT phase, comes in. This is where those pre-trained models get honed into versions that are much more adept at understanding and responding to natural language instructions.
So they're essentially training them to be more conversational and interactive.
Exactly. And with Gemma 3, they've really upped their game in terms of their post-training methodology.
What's new and improved in their instruction tuning process?
They're still using knowledge distillation, again, learning from a larger, more capable instruction-tuned teacher model.
So the master chef is back.
Right. and are also leveraging reinforcement learning, fine-tuning, using improved versions of their bond, warm, and warp frameworks.
Bond, warm, and warp. Those are some pretty interesting acronyms.
They are, and they're all about shaping the model's behavior to align with desired outcomes.
Huh. So what kind of signals or rewards are they using in this reinforcement learning process? What are they telling the model to prioritize?
It's a diverse set of rewards. They want the model to be helpful, accurate in areas like math and coding, capable of reasoning, good at following instructions, and proficient in multiple languages.
So they're casting a pretty wide net in terms of the model's capabilities.
They are, and importantly, they're also training it to minimize harmfulness.
Mhm.
They're drawing on techniques like learning from human feedback, evaluating the results of code execution, and comparing answers to known correct solutions in things like math.
So it's not just about capability, it's also about responsibility.
Exactly. Safety and ethics are woven into the training process.
And they're also being very selective about the data they use for this post-training refinement, right?
Absolutely. They meticulously curate and filter the data to maximize performance and minimize potential issues.
Like what kind of issues?
Well, they're careful to filter out examples that could inadvertently expose personal information, lead to the generation of unsafe content, cause the model to misidentify itself, or are simply redundant.
So it's about being both effective and responsible.
Precisely. They also include data that encourages the model to provide better context, to express uncertainty appropriately, and to decline to answer requests that are inappropriate or harmful.
So they're training it to be more self-aware and to recognize its own limitations.
Right. The goal is to create a model that's helpful, factual, and safe.
I see. Now, I noticed some details about specific tokens they use, like BOS and different end-of-generation tokens. Can you explain those?
Sure. So both the pre-trained and instruction-tuned models use a special BOS token at the beginning of any input text. It signifies the beginning of the sequence.
Okay, that makes sense. A kind of starting flag.
Right. And the key difference on the output side is that the pre-trained models use an EOS token, which stands for end of sequence, to signal the end of their generated text.
Okay.
But the instruction-tuned models use an end-of-turn token to indicate they've completed a response in a conversation.
So it's a subtle difference, but important to understand if you're working with these models directly.
Yes, definitely.
Okay, that's really helpful. So after all this training and fine-tuning, how do the Gemma 3 models actually perform? Let's talk benchmarks and evaluations.
Right, let's see how they stack up.
First up, the LMSYS chatbot arena. This is where different language models go head-to-head anonymously, and humans decide which responses they prefer.
It's a really interesting way to evaluate these models in a more real-world conversational setting.
Yeah. So how did Gemma 3 do?
The 27 billion parameter instruction-tuned model, Gemma 3 27BIT, achieved a preliminary ELO score of 1338.
1338. Where does that place it on the leaderboard?
It puts it in the top 10 and well ahead of Gemma 2.
So a significant improvement.
And what's really remarkable is that it's even holding its own against much larger models in text-based evaluations, models like DeepSeek V3 and LaMMA3, which have 405 billion parameters.
Wow, that's impressive.
And, of course, those larger models don't yet have the visual understanding capabilities of Gemma 3.
Right, so size isn't everything.
It's not. Gemma 3 is punching well above its weight.
What about more traditional benchmarks? How does it perform on those standardized tests?
Across a whole range of benchmarks, things like MMLU Pro for advanced reasoning, Live Code Bench for coding skills, Bird SQL for understanding SQL, GPQA Diamond for expert-level question answering, Math for mathematical problem solving. The Gemma 3 IT models consistently outperformed the previous Gemma versions.
So a clear step forward across a variety of different skills.
Yes. And while they haven't done direct head-to-head comparisons with external models because of differences in evaluation setups, the general trend is very positive. They've also seen competitive performance with models like their own Gemini 1.5 in their internal evaluations.
That's really encouraging. It sounds like they've made significant progress on all fronts. Now, their technical report also included some interesting ablation studies where they really dug into the impact of specific architectural design choices. What were some of the key takeaways from those experiments?
The ablation studies are really valuable because they help us understand why Gemma 3 performs so well. For example, they looked at the ratio of local to global attention layers.
Right. We talked about how they use this interleaving strategy with 5 local layers for every 1 global layer.
Yes, and they found that even pushing that ratio further to 7 local layers per global layer had minimal impact on perplexity.
Perplexity.
It's a measure of how well the model predicts the next word in a sequence. So this suggests that their architecture is extremely efficient. They can shift the balance heavily towards local attention without sacrificing performance.
That's fascinating. What about the size of the sliding window used for those local attention layers? Did they experiment with that?
They did. They found that they could reduce the size of the sliding window significantly without impacting performance. This means that those local layers can be quite focused in their attention, which helps to keep things computationally manageable.
So it's about finding the sweet spot between the scope of attention and computational efficiency?
Right. And of course, one of the big questions was how this new local global attention strategy would impact memory usage, particularly when dealing with those 128K token sequences.
Right, because that was a major concern with long context windows.
And the results are really impressive. They showed a substantial reduction in memory overhead for the KV cache during inference.
So they've effectively tackled the KV cache explosion problem.
Exactly. When compared to a setup with only global attention, their new strategy with local and global layers combined with the optimized sliding window leads to a big decrease in memory footprint. They even quantified these savings, showing a significant drop in memory consumption compared to global-only models.
So it's not just theoretical, they've actually demonstrated the practical benefits of this approach.
Absolutely. And they also detailed their method for enabling this long context, pre-training on 32K sequences, and then scaling up to 128K using ropey rescaling.
Right, we touched on that earlier. How did that strategy work out?
It seems to be very effective. The models generalized well to the longer context length. However, they did find that pushing the scaling beyond 128K started to lead to a performance drop.
So there seems to be a limit, at least for now, on how far they can push the context window.
Yeah, it's not infinite, but 128K is already a huge step forward.
For sure. What about the knowledge distillation aspect? Did they discover anything interesting about the size of the teacher model?
Yes, they did. They found that for shorter training durations, using a smaller teacher model can actually be more beneficial. But as the total training time increases, the larger teacher models lead to better performance in the long run.
So the optimal teacher size depends on how much time you're willing to invest in training.
Precisely. It's a trade-off between training time and performance gains.
Interesting. And since Gemma 3 now has these visual capabilities, what did their ablation studies reveal about the vision encoder?
They looked at the impact of the encoder's resolution and found that, in general, higher resolution encoders resulted in better performance.
So it pays to have a sharper eye, so to speak.
Right. They also emphasized the significant performance gains they achieved with their pan and scan technique, especially for tasks like reading text within images or handling images with different aspect ratios.
So pan and scan is definitely proving its worth.
It is. It's a key part of their vision solution.
Now, let's shift gears and talk about something that's always a concern with large language models: memorization and privacy. What did the Gemma 3 team find in this area?
Encouragingly, they found that the Gemma 3 models showed a significantly lower rate of memorizing long-form text compared to their previous Gemma and Gemini models.
So that's a positive sign.
Yes, and they looked at both exact memorization, where the output is identical to something in the training data, and approximate memorization. They found that more of the memorized content was approximate rather than exact. And importantly, when they scanned the memorized outputs for personal information using Google Cloud's Sensitive Data Protection Service, they found none.
That's really reassuring. It suggests a low risk of personal data leakage.
Yes, definitely a good sign.
Okay, finally, let's touch on responsibility, safety, and security in the development of Gemma 3. How are they approaching these critical issues?
They really emphasize that responsibility, safety, and security are core principles guiding the entire development process.
So it's not just an afterthought, it's baked into their approach from the start.
Exactly. They have enhanced safety measures integrated throughout their workflow, and they're constantly refining their processes.
And how do they think about the potential risks and benefits of releasing these powerful models to the public?
They carefully consider the potential benefits of OpenAI, while also being very mindful of the potential for misuse.
It's a balancing act for sure.
It is. They point to examples like Shield Gemma 2, an image safety classifier built using Gemma 3, as an example of a socially beneficial application.
That's a great example.
They also conduct baseline assurance evaluations to see how often the models violate their defined safety policies, and they found a very low violation rate for Gemma 3.
So they're testing the models rigorously to make sure they're behaving as intended.
Exactly. They've even assessed the model's knowledge in sensitive areas like CBRN materials, chemical, biological, radiological, and nuclear, and found it to be limited.
So they're being very thorough in their safety assessments.
They are. They want to be as transparent as possible and demonstrate that they're taking these issues seriously.
That's crucial for building trust in these technologies. Okay, so let's wrap this up. What are the key takeaways from our deep dive into Gemma 3?
The big ones are the new multimodal capabilities, the massive 128K context window, and the enhanced multilingual understanding and generation. And all of this is designed to be accessible to a wider audience, running on everything from laptops to high-end GPUs.
And those architectural innovations, like the interleaved local and global attention layers, are really what makes that long context window possible without running into memory bottlenecks.
Absolutely. They've really pushed the boundaries of what's possible with these models.
And it's encouraging to see the lower memorization rates and the proactive approach to safety and responsibility.
Yes, it's clear that they're thinking carefully about the broader implications of this technology.
So as you're listening to this, I want you to think about the potential impact of more capable and efficient open source AI like Gemma 3 in your own world. How could the ability to process images and understand vast amounts of information change how you work, how you learn, how you create? It's something to really ponder. Thanks for joining us for this deep dive.
Thanks, everyone.
We'll see you next time.
See you then.
Bye.